Mr. Decis is back again. Get ready for another one. Alright, today we're going to look at a new term that is called inscribed angle and intercepted arc. Remember, an arc is a portion on the circle, so a part of the track of the circle. So inscribed angle is an angle that is its vertex lies on the circle. An inscribed angle is an angle where its vertex lies on the circle. So it's all about the inscribed angle. If you are inscribed angle, meaning that the vertex of this angle must be stays on the circle. Alright, so let's get our magic red pen. Alright, this is the angle that is formed, angle 1. This is one of the secant, and the other the secant that form the angle. Right? The intercepted arc, this is the part that is called the intercepted arc. Right? This angle is your inscribed angle. Its vertex lies on the circle. So that is an inscribed angle. It is an angle where the vertex lies on the circle. There's a special relationship between the inscribed angle and the intercepted arc. So it says that if an angle is inscribed in a circle, then its measures is half of its intercepted arc. Listen again. If an angle is inscribed in a circle, then the measure of its intercepted arc is half of the intercepted arc. Alright? To find an inscribed angle, identify the intercepted arc and take half of it. Right? Whatever the intercepted arc is, slash it in half. That will give you the inscribed angle. On the other hand, if you know the inscribed angle, in order to find the intercepted arc, just multiply it by 2. That will give you the intercepted arc. This is the same relationship between radius and diameter. Right? This is the term of circle. Remember, the radius is half of d. So your radius is your inscribed angle. Consider the radius is the inscribed angle. That's how to connect them, make a connection with that. Then the diameter will be your intercepted arc, meaning that the intercepted arc, so when you're looking for the intercepted arc, whatever the inscribed angle is, you multiply it by 2. Therefore, that will be 2r. Remember, diameter is 2r. Therefore, you will see that the intercepted is 2 times as much as the inscribed angle. Those are the relationships that you have to create. Meaning that if I have this angle which is 150, if I have this arc which is 150 degrees, right? Since I'm looking for this angle 1, so the only thing I have to do, it says the inscribed angle is always half of its intercepted arc. So it says, you know something? Half of something is half of something. Take half of it. Half of 150. In this case, measure of angle 1 will be 75 degrees. That's all it's telling you. Same thing. If I don't know what the intercepted arc is, so this is my inscribed angle. In order to find the intercepted arc, I'm going to multiply by 2, then that will give me 150. Vice versa. This is the relationship. It's either half of the intercepted arc or the intercepted arc is 2 times as much as the inscribed angle. This is a relationship that you have to make. So this is the same thing here. I have this example here. This is my intercepted arc, and this is my inscribed angle. Therefore, measure of angle M will always be half of 150. So the arithmetic half of 1/5 of 100, it says it was 50 degrees. This will be 50 degrees. This is the relationship. All right? That's what it is. Now, I have this arc here. Let's say this arc is 120 degrees. And the inscribed angle that is formed with this arc is that angle D. Therefore, in order to find angle D, I will take half of arc AB, whatever half of 120 is. That will give image of angle D. Therefore, half of 120 is 60. This angle is 60 degrees. Right? However, this is called the central angle. The central angle C will be 120 degrees. So do not confuse central and inscribed. Central, the vertex is in the middle, is in the center of the circle. That is called central. Inscribed means the vertex must be on this circle. So those two are going to play trick on you, vice versa. So be aware of those two terms. Same thing here. I have this inscribed angle. The inscribed angle is 115. See? This angle here is my inscribed angle is 115. 150. Now I need to find this. So in other words, if I know my radius, I cannot find my diameter. I have to multiply by 2. Therefore, this will be 2 times 115. Whatever 2 times 115 is. The last time I checked, 2 times 115 is 230. So the arc ZWX will be 230 degrees. Then you're done. Right? This is very simple. Here, this is my inscribed angle. My inscribed angle is X. Vice versa, we just did that the same way. If the intercepted arc is 230 and we just do that, then what is half of 230? 115. X will be 115 degrees. Then you boom, you run with that. Here, angle J is the right angle, meaning this is a 90-degree angle. So I need to find the arc, intercepted arc KL. So I'll say 2 times 90, that will give me measure of arc KL. In this case, KL will be 180 degrees. This arc will be 180 degrees. Then you're done. So, last one. I have this inscribed angle here. This is my inscribed angle. The inscribed angle is 75. And this is my intercepted arc. Therefore, in order to find the intercepted arc, I have to multiply my inscribed angle by 2. That will be 2 times 75. In this case, 2 times 75, this will give me 150 degrees for the intercepted arc. The intercepted arc will be 150. Y will be 150 degrees. Now, in order to find Z, this is my inscribed angle. This is my angle. And guess what? My intercepted arc is the same. Right? So if this is 150, I will take half of 150. Therefore, this will be 75 degrees. If you have two angles that share this same intercepted arc, therefore those two angles will be congruent. So this is what we want to expose you to. Inscribed angle. Remember, an inscribed angle is an angle that is formed where its vertex lies on the circle. It is an angle that formed on the circle. The vertex is on the circle. And if you find the inscribed angle and just match its intercepted arc, trace its intercepted arc, whatever the intercepted arc is, you take half of that. So compare it with the relationship with radius and diameter. Instead, this is continue in our lesson where we're going to look when we have two inscribed angles of a circle intercept the same arc, then the two angles will be congruent. In this case, what they are trying to tell you, we have this inscribed angle here, angle A. Let's trace angle A. If I trace angle A, the inscribed angle, if I trace the angle that is formed, I will have BC as the intercepted arc. Right? Let's call this angle X. Then I have another inscribed angle here, angle D. Let's trace the intercepted arc. as you can see, those two angles share the same intercepted arc. Any two angles that share this same intercepted arc, they will be congruent, meaning that angle X will be congruent to angle Z. Measure of angle A, which is X, will be congruent to measure of angle D. Likewise, we have an inscribed angle here, B. Let's trace it to see what happens. When I trace it, it gives me this angle here. The arc, this is the arc AD. And if I do the same thing with inscribed angle C, when I trace it, give me that, and you will see that they share this same intercepted arc. Therefore, angle B will be congruent to angle C. Any two angles that share this same intercepted arc are congruent. So that's what I'm trying to convey to you. So in order to see those things, so when you're doing your work, you have to use multiple colors. So in this case, they're asking me to solve for the variable. So the only thing I can see, they give me this angle here, and it's have angle D. I'm going to trace it to see what happens. So when I trace it, I identify this intercepted arc here. Since this is an inscribed angle, 47, so to find the intercepted arc, I'm going to multiply it by 2. When I multiply it by 2, that will give you 14, 8, this, and the intercepted arc is 97. So let me see what relationship it has to angle G, which is represented by X. So let me trace this inscribed angle here. When I trace it, this is the first secant. I trace it, this is the second secant. So there go what it's giving me. It's giving me that intercepted arc, which is 94. In order to find the inscribed angle, I will take half of 94. Half of 94 is 47. Therefore, this proving you angle D and angle G are congruent because they share the same intercepted arc. Any inscribed angle that share the same intercepted arc will be congruent. So this is the moral of the story. Here, I have this angle which is 45. Then if I trace it, there go what I will have. I will end up with that. In this case, that will help me find anything that I want. This will be 90. 2 times 45 is 90. So when I look at angle X, which is represented by letter X, see, and I trace it, this happens to be the same intercepted arc. So if those two angles will be congruent, half of 9 is 45. So you can go exactly, X is 45 degrees because they share the same intercepted arc, which is arc QR. They have the same intercepted arc. Whatever the measure of QR is, you take half of that. So let's explore how we will see about that. So in this case, this is this. If this is 40, we can find this. That's 85. This will be 95. This also will be 95. We don't need to do a lot of work. That will give you 140. This will be 40. So you do not have to do all that to do that. So the only thing you have to do, alright, share which arc they share. This angle R and Q are supposed to be congruent. So let's say we did not know that. Right? Let's see. This is the arc they share. And this is my inscribed angle. If this is 40, this has to be 80 degrees. Now when I trace this angle Q, the inscribed angle represented by Y, this is the share the same arc. You have to say these two angles are congruent. This has to be 40. When you take half of 80, that will give you 30. That proves you that any inscribed angle that share the same intercepted arc are congruent. Yes, indeed it is. This is Mr. This is. Mr. This is resume in property of circle. So where we have to continue our topic. So I said that If a right triangle is inscribed in a circle, then the hypotenuse is a diameter. If a right triangle is inscribed in a circle, then the hypotenuse is a diameter. Conversely, if one side of an inscribed triangle is the diameter of the circle, then the triangle is a right triangle, and the angle opposite the diameter is the right angle. So let's explore what they're telling you. As you can see, we have the joint AC. Excuse me. AC is the diameter, right? Because it passed through the circle. We know AC is the diameter. So I'll say this is the diameter of the circle. Let's label that so you can see what's going on. Right? If this is the diameter, for me today is the half of a circle. This is the same as circle. This will be 180 degrees. No doubt about that. Now, if this is 180 degrees, so let's explore the inscribed angle B. If we take inscribed angle B, we expand those chords as a secant. As you can see, the intercepted arc of AC is 180. So the inscribed angle have to be half of the intercepted arc. Half of 180 is 90. Therefore, this is a right triangle. This telling you if you have an inscribed angle and the intercepted arc is the same as circle, then the hypotenuse is the diameter of the circle. So we conclude that the hypotenuse is the diameter of the circle. This is indeed a right triangle. Remember, whenever you have a right triangle, you have the right to use a square plus b square is equal to c square, which is the Pythagorean theorem. In this case, we need to be aware of that. Whenever we have a diameter and we have an angle that is inscribed of the circle, we have to explore if one of them is not a right angle. In this case here, we identify Km as the diameter. If Km is the diameter of the circle, then we have to know that this is a semicircle. And this is a semicircle, this will be 180, and the inscribed angle L is half of the circle. Half of the circle is 90. In this case, X is the right angle. Since now we have a triangle, those two angles K and M are supposed to be complementary. So if this is 90, this has to be 50 degrees. So they are all the things we can find. Now, since this is the inscribed angle, here angle M, this is 40 degrees, so arc KL will be 80 degrees. And also, we have this inscribed angle K, inscribed angle K. If we express that, continue that, this is 50, then 2 times 50, that will be 100. That's how you will see that it's 360. This is 80, this is 80. Remember, this is also half of a circle. For me today, it's half a circle. Those two have to be added up to 180, and 180 plus 180 is 360. So be aware of that. In this situation, we have diameter here. This is your diameter. AB is the diameter. Q is the center of the circle. And we know this is half of the circle. This is the semicircle, 180. If we expand, if we look at this inscribed angle, we know this will be a right angle. So half of 180 is 90. The equation will be 2x is equal to 90. And in order to find x, we'll have to divide by 2. In this case, x will be 45 degrees. That was we said this is properties of circle. We nice one. Steady. Then we will resume when we come back. Make sure you make the